Let's quickly review our dataset. For this, we will use codebook command. So this is our descriptive statistics. The first variable is salary. You can see our dataset contains 1028 number of observations across 7 key variables. The primary outcome variable is salary. The salary ranges from 12.46 to 203.99. A very widespread, nearly 16-fold difference from minimum to maximum. Then standard deviation is 23.81, indicating substantial variation around the mean. The mean 49.36 is higher than the median 44.56, which indicates that the distribution is rightly skewed, meaning a smaller number of individuals earn very high salaries, pulling the average upward. The 10th percentile is 24.26 and the 90th percentile is 79.68. So the top 10% earn more than 3 times the bottom 10%. So this wide variation is exactly we need to investigate whether salary differences are systematically linked to gender, sector, or location rather than just productivity related factors like experience or education. So for this we will use regression models to isolate the effect of each variable while controlling for others. Say for example, if females earn significantly less than males with the same education and experience, then what would be the evidence of potential discrimination? Next is the gender variable. You can see it is nearly distributed and to a balanced level, which is ideal for comparative analysis. In our models, we will treat this as a binary predictor to test whether there is a gender wage gap after controlling for others. Then we have age variable ranging from 18 to 70 with the mean of 44 years. This represents a broad working age population and it can serve as a proxy for maturity, experience, or career stage, and we will include it as a control variable in our regression model. Then we have education parameters which ranges from 6 to 20 years with a mean of 13.79. Education is a key productivity determinant and we will control for it to ensure that any salary difference we observe are not simply due to differences in educational attainment. Then we have next variable service experience measured in years ranging from 0 to 33.1 with a mean of 13 years. This variable captures work experience which is an other important determinant of earnings. We will use it alongside education to separate productivity-driven wage differences from discrimination-driven differences. Then we have a parameter location is also important because urban labor markets offer higher wages due to the cost of living and concentration of high-paying industries. We will test whether the urban-rural wage gap persists even after controlling for other factors. Then we have a sector variable that distinguishes between private and public sector employees. Public sector jobs often have different pay structures, benefits, and rates compared to private sector jobs. This variable allows us to examine whether there is a sectoral wage premium and whether discrimination pattern differs across sectors. So across the data set, now our goal is to determine number one, which factors significantly predict salary. Number second, after controlling for productivity related factors, do gender or location or sector still have significant effects? If significant, then what is the magnitude of these effects and do they indicate potential discrimination? So we will explore this in the next modeling session. Let us start decomposition analysis using noisily function. We will drag here salary as a dependent variable because by default the worst variable is always taken as a dependent or response variable. Then we will have education variable and service experience. Then we will have age variable as well. So we will also use urban WME and sector dummy. So here for comma and then by we will segregate into male and female groups by a gender variable. So we will close this in brackets. And Y. So now our stata command is complete. We will approve this, and this is we have complete output for the threefold decomposition analysis. These commands explore the threefold decomposition, which is the default approach in Oaxaca, dividing the total gap into endowments, coefficients, and interaction. We will discuss each group one by one. Now let us discuss each model in detail. The first we will talk about model for group 1. You can see we have coded a gender dummy variable 0 for females and 1 for males. So the model for group 1 means the model for females. For group 1, the regression model includes 5 predictors and used 516 number of observations. The overall model is statistically significant, indicating that the predictors showed a meaningful relationship with the dependent variable. The model accounts for 26.02% of the variance in the outcome variable, with an adjusted R-square of 25.29%. The negligible difference between the R-square and adjusted R-square values indicate that the model is parsimonious and does not suffer from overfitting, confirming that the included predictors contribute meaningful explanatory power without unnecessary redundancy. The root mean square error is 10.145. The adequacy of this error should be assessed relative to the scale and variability of the dependent variable rather than against a universal threshold. In the female model, the model's typical prediction error is about 29% of the mean salary, which is fairly an acceptable limit. Now, looking at the coefficients, you can see that each additional year of PhD education increases female salary by 1.63 units. Similarly, each additional year of service experience increases female salary by 0.48 units. Similarly, you can see that urban females earn 2.90 units more than the rural females, and private sector females earn 2.006 units less than the public sector females. Thus, all the variables have significant role towards the salary package except A. Now, the model for group 2, that is the model for male group. The regression analysis is based on 512 number of observations. The model is statistically significant and explained 16.86% of the variation in the dependent variable. Now, looking at the coefficients, you can see that each additional year of PhD increases male salary by 2.83 units, and each additional year of service experience increases male salary by 0.95 units. Urban males earn 7.3 units more than the rural males. If you compare model 1 with model 2, you can see that males get 1.2 units more return per PhD years and get nearly double the return to the based on the experience. males get 4.23 units more salary than their urban counterparts. Notice that the private sector penalty is not statistically significant for males, unlike for females. The public sector wage advantage appears to be confined only to the female employees, as the sector coefficient is non-significant for the males. This is the combined model estimated using a pooled sample of 1028 number of observations. In this model, females serve as the reference group and male as the comparison group. Here you can see the overall effect of the model. It shows that the group 1, which is the group for the females, has average salary of 34.17, and for the male group the average salary is 64.70. So there is a huge difference between the two groups, about 30.50 units. Then we have endowments component, which is the explained part of the model. It says that if females had the same characteristics as males, about 13.78 units of the gap may be disappeared. So this is roughly about 45% of the gap. Then we have coefficient to the tune of 23.07 units, which explained unexplained part of the model. So it indicates that even with the identical characteristics, a gap of 23.07 units remains as such, and this is the portion of the model often attributed to the discrimination component. Then we have a positive interaction of 6.36, which says that the combination of differences in characteristics and returns actually reduces this gap to some extent. Then we have a detailed breakdown which shows us which variable exactly drive the gap. So the endowment component represents the portion of the salary gap associated with the differences in observed characteristics between the two groups. PhD contribute 7.16 and service experience contribute 6.70, and both are statistically significant. Then we have coefficient component, which represents the differences in estimated returns to the observed characteristics between the two groups. PhD has the largest contribution at 18.04, followed by service experience 7.80. Urban variable 2 is significant to the tune of 2.51 units, and all the three components are statistically significant. Then we have interaction term, which is positive and statistically significant. This component captures the combined effect of differences in characteristics and differences in their estimated returns. You can see that the PhD contributes 3.04 and service experience contributes to 3.31 units, and both are statistically significant. On the whole, we can conclude that these results indicate that both differences in observed characteristics and differences in coefficients contribute to the salary gap. The coefficient component is larger in absolute magnitude than the endowment component, suggesting that differences in knowledge. Look at an alternative way to decompose the wage gap, the twofold decomposition using pooled method. This is often called the Newmark approach. The pooled command uses coefficient from a pooled regression as the reference wage structure, whereas previously used noisily command uses females as the reference group. So we now run the pooled command. So here is the output before us. So you can see that the key difference is the pooled option. Instead of using group 1 as reference and group 2 as comparison, Stata estimates the pooled regression over both groups combined to determine how a non-discriminatory wage structure would look like. This is widely considered a more neutral benchmark because it doesn't privilege either group's pay structure. So let's see what the results tell us. First, look at the formula. The explained part. This takes the differences in characteristics between females and males and multiplies it by the coefficient from the pooled model. So this captures the portion of the gap due to differences in endowments using a neutral benchmark, whereas the unexplained component, it's quite a complex formula. It measures how far each group's returns deviate from the pooled returns. Essentially, it captures the differential treatment of both groups relative to the pooled method. Notice that in the two-fold decomposition, there is no separate interaction term. The interaction effect from the threefold model has been absorbed into the unexplained comp. This simplifies interpretation but also changes the magnitude of the unexplained part. Now look at how the two-fold decomposition splits this. See that the explained part is 10.40. This is the endowment effect using the pooled coefficient. You can say that 34% of the total gap is explained by differences in characteristics like education and experience. And you notice that the unexplained part is 20.09 units. This is actually the structural effect. About 66% of the gap remains unexplained. It means that even with identical characteristics and a neutral benchmark, a large gap persists. So now we look into the detail of the explained component. Females have lower average PhD level, which accounts for about 5.17 units of the gap, and difference in work experience explained another 5.32 units. So differences together, these two factors dominate the explained component. This suggests that closing the gap through the explained channel would require improving females' access to higher education and building their work experience. Now come to the unexplained part, the structural effect. The return of the PhD education contributes nearly 17 units to the unexplained gap. Means females are significantly undercompensated for their PhD relative to the pool. Similarly, females receive lower returns to experience than the pooled norm, contributing nearly 6 units to the gap. However, in all the regression analysis we have done so far, the age does not play a meaningful role. Age does not play a meaningful role. In summary, we can say that the blind Oaxaca decomposition reveals that the gender wage gap is predominantly driven by structural inequalities rather than differences in productivity-related characteristics. While females lag behind males in education and work experience, which together account for the entire explained component. The much larger unexplained component indicates that the females receive significantly lower returns to those very same attributes. Closing the gap will require not only investments in the female education and experience, but also policy intervention to address unequal returns and structural discrimination in wage setting practices. So this is all about the pooled method of Oaxaca blind decomposition analysis.